Hello guys, in this tutorial we're going to learn how to solve the differential equation in this form where b1 and a2 are equal but opposite in sign. So I'm not going to solve this differential equation using the common approaches that we studied in our school or what is taught by our teachers. I'm going to use a completely different approach to tackle this problem, and it is not that hard, which I learned from school, but you can get the answer within few seconds. So let's begin with an example. Suppose you have to solve a differential equation of this form. So first step is to look at the coefficient of y in dy part and coefficient of x in dx part. Saying dx part, I mean to say that if dx is in the denominator in this part, then the denominator part will be the dx part, and if dy is in numerator part, the numerator part will be the dy part. So the coefficient of y in dy part is -5 and the coefficient of x in dx part is 5. So if we compare these values, -5 and 5 are equal but opposite in sign, so we can use this rule. So let's proceed. The first thing I do is we detach and bring to the constant. So actually you cannot detach d from dy and d from dx, but since it's a mathematical trick, you can do it. For remembrance, what I say is, look at those constants of x and y. Y is preceded by a constant and x is preceded by a constant, but 4 doesn't have any variable to it. So what we do is we give 4 and 9 the variable d. We detach d from here and bring it to this side. So what actually d means is, d means nothing. For our purpose of simplicity, we have brought it here, and d, just remember d as double or multiply by 2. And with a surprise, this is the result of the solution of the differential equation. Now you can simplify it. Just pause the video if you want to look the simplification. And at last, since we are integrating it to get the result, we need to add a constant, and by taking 2 common we get the answer as this. So the solution of this differential equation is this equation. But why does this rule work? What is the mathematics behind it? Let's study in deep. Let us consider a function in the form f equals ax squared plus by squared plus 2hxy plus 2zx plus 2fy plus c equals 0, where the constants shown in green color are simply constants. They can be any values. So you may have learned this function represents either a pair of straight lines or a parabola or ellipse or hyperbola. It doesn't matter what does it represent, we just have a function in this form. So let's differentiate this function with respect to x. What we get is, since this is the implicit function in x and y, for this we can easily use this formula to get the differentiation. So df by dx. So df by dx means just the partial derivative of f with respect to x, and df by dy means the partial derivative of f with respect to y. So we can get this value, and taking 2 constant we can get this value for dy by dx. Let's keep it aside, and what we can see here is that for this type of function, the coefficient of y in dy part is -h and the coefficient of x in dx part is +h. So what was my idea of solving this type of differential equation? What I did was I detached this d and brought it to the constant like here, and I also said that d is same as double or multiply by 2. So I multiplied by 2 and just simplified it. After simplifying, what can we get is this equation, and simplifying we get the same equation as above, and after adding constant we get the same equation. So the main idea to solve this problem was that we already know that the solution of this differential equation in this form will give the result of this function, and my idea is preferable also in the sense that we need not see what the variables a, h and g are. But remember, it won't work for the following differential equations. It may seem similar to the given function, but just look at the coefficient of y in the y part and x in the x part. The coefficient is 1 and here is also 1. They are same, but they are not different in sign, so we cannot use the differential equation. So look at the solution is also not in the format of what I had shown before. Similarly for this function also the coefficient is 1 and these are similar but also similar in sign, so we cannot use this function. So the solution is in terms of trigonometric and logarithmic function. So you must be aware that the similar type of differential equation can give trigonometric or logarithmic or exponential functions, and also so you must be aware of the constant which should be used in differential equation, and that will work. So maths is all about patterns, just recognize it. Thanks for watching.